Okay. Good evening, everyone. Again, we're going to do a lesson with calculus. We're going to find the volume of a solid of integration, by integration. We're going to particularly a solid formed by rotating a bounded region about an axis. So now let's look at to get a region, we need to set a bounds on it. So here are our boundary points, our boundary functions. Y equals radical x minus 1, x equals 2, x equals 5, and y equals 0. So we got, that's this region where the rectangle is. And let me shade it. Now be careful, that's this shaded region here, where the rectangle is. Now, it's not this region here. Let me put a blue O where we don't want to include. So I'll put no here. So it's the green region, but we don't want the no region. I put the word no there. So that's the 2D region we want to look at. It's because remember our bounds go, it's not just radical x minus 1, it's x equals 2, x equals 5. So it's this chopped off, it's the region with basically this got chopped off with my hand, not including what my hand's blocking. So there's the region, what you can see. So now let me get rid of the shading here because my rectangle is what I want to pay attention to. Observe, and I'm going to move the camera around so you'll have to forgive me. So pardon me while I do this. Now, if you'll observe, well, maybe you got a little too close there, that the region, this is an infinitesimal rectangle of infinitesimal thickness along x. And we did you put the infinitesimal thickness along the axis that you're integrating with respect to, which is x. So dx there, rad x minus 1 is the height. So that's the infinitesimal rectangle. Now that rectangle is important. Notice that rectangle again, very importantly, it doesn't leave, it's a lower limit rectangle so it can be contained entirely within our region. It doesn't have to transgress outside of our region. That's important, and I don't think enough books amplify that. So keep that in mind. Now this is just the radical function. This curve right here is just our radical function, the upper curve, the upper bound, so to speak. The lower bound is just y equals 0. Now, here's the deal. Imagine in your mind rotating this region right here about the x-axis. So we do that rotation and you'll get, pardon me a minute, I'll try not to make you dizzy. We get this 3D bowl. And I tried to draw an infinitesimal cylinder in that bowl. It's hard to do, so I went ahead and did a second take. This is the infinitesimal cylinder whose thickness is actually very thin, dx. I had to draw an exaggerated finite thickness. Now the radius, which I'm having to zone in on, that's your radical x minus 1. That's the radius. Because remember, the height of this guy determines how far it comes out, which in other words it determines the radius, or how far really it comes down, I should say. And that radius, rad x minus 1, that height, excuse me, determines this radius in blue. And dx, well, that's just dx as it was over here. So there's your, now we're going to, basically you can think of this as adding infinitely many infinitesimal cylinders and getting the volume. Now for each infinitesimal cylinder, I kind of forgot to point this out in the last video, but it didn't really hurt much. But now it's pi r squared h, right? The volume of a cylinder from geometry is pi r squared h. Now this infinitesimal volume, dv, is pi times rad x minus 1 quantity squared dx. Now observe that rad x minus 1 squared is just ordinary x minus 1. So that we can clean that up, and we'll do that in a minute by algebra. But until then, just bear with me. So now let's go to the math, the raw hard, the math. So we integrate along the dv's. The volume of this whole bowl is the integral of our boundary, the integral of excuse me, that V shouldn't be there, so let me kill that V. It's just the integral along our DVs. Okay, and this A and B aren't really serving much of a purpose. This first step is just more for intuition. So we're integrating our infinitesimal volumes. Now here we do need our boundaries. From x equals 2 to x equals 5, we're putting V, our dV rather, in terms of x. And it's this guy. We're integrating from 2 to 5. Remember, so the integral, well, let me move, excuse me, pardon me. Let's get this in view here. So that's integral dV, which is equal to, I almost made it look like dV equals this. I need to move this dV closer to the integral. So let's move this dV in. So there's that. And that's integral from 2 to 5 of this guy. Because remember, that's integral 2 to 5 of your dV, which is, dV is this guy. So you got that, and that's integral 2 to 5. Now if you square a radical, you just get the naked expression. And I forgot I need to put my pi right here. So let me do that. So my pi needs to go right there. And you could take it out the integral if you wanted to. But when you do the integral, you get 15 halves pi. You just go through your usual integration steps. I'll let you, now that part I'm going to let you do. I don't want to belabor that part. But I just want to show you how to get it set up. Again, if you rotate about a horizontal axis, you integrate with respect to x. And if you rotate about a vertical, then you integrate with respect to y. Now, what I can't emphasize enough is that this lower limit rectangle stayed within our region. Now, if it didn't stay within our region, then that would slightly complicate the integral. Not really badly, but it would some. I'll burn that bridge when I get there. But there's our dx and our radx minus 1. So we just integrate, we integrate with respect to these infinitesimal volumes here. Which is really a lot, really if I was to truly do it justice, it would be so tiny you couldn't see it. You know, but you probably wouldn't be able to read it so well. That green one is closer to the truth, but this guy right here, this little guy, but you can't read that so well, so I wanted to give you something you could read. So, but anyway, that's that. And again, our x limits went from 2 to 5, and that's why we integrated it along from 2 to 5 there. So any questions? Again, let me emphasize, this rectangle is important. You need to draw it. The book doesn't really tell enough about that. Rectangle determines how everything's going to go. But anyway, hope this helps, and I'll do more. Thanks.